Hello guys, welcome back to Chem 2C this time, back to making videos on Chem 2C. Haven't made them in a while. And we're going to be starting with chapter 11, the first part of chapter 11 called Galvanic Cells. So before I get into galvanic cell, I'm going to do a little bit of review from oxidation, reduction, all that stuff, oxidation states, electrons. So electrons, usually written like this, have a negative charge. That's just one thing that, well, you should know by now, hopefully, in chem. And we're going to be applying this common theme to the rest of about this chapter, specifically galvanic cells in particular. So when an element has, so let's say, I'm not going to use zinc, I'll use a random element like aluminum. This is aluminum. It doesn't have any extra charges, but then when you write it like this, Al minus, that means it has an extra electron, because now it has an overall negative charge than what it should be, than the standard to neutral. And then when it's like this, Al plus, that means it lost an electron, because then it will be 0 minus -1. The charge of an electron, it becomes +1. And right here will be 0 plus -1, which means it gained an electron, which made it -1. So that's just a review about how when the element gains an electron, it becomes positive, and when the element loses an electron, it becomes negative. And another thing to review is oxidation is losing electrons. So in this case, when it loses electrons, when it becomes positive, that's oxidation, losing electrons. And then reduction means gaining electrons. And how I remember this is, I know there's an acronym called oil rig, where O is losing, and let me write it out. Oil rig. O is losing electrons right here, and then reduction is gaining electrons. But how I remember it is through reduction. Reduction means, for me, reduction in the charge. So it goes from this to this. The charge went from 0 to -1, so that means they reduced. And then oxidation means increase in the charge, where it goes from this to this, which means the charge went from 0 to +1. And then, when the charge is reduced, it means it gained electron, and when it's increased, it means it lost electrons. That's just how I remember it. So anyways, a half reaction, so an oxidation half reaction, I'm going to use zinc now, which is just the standard for galvanic cells. You're probably going to see it a lot, where something like this, zinc on its own, the neutral form of zinc, becomes zinc 2 plus, it becomes aqueous now, because most, so this is a metal, right? And then when a metal has a cation, when it has the metal plus some sort of charge, 2 plus, 3 plus, it's usually aqueous. It becomes a cation, and it's aqueous, and then it goes from solid to aqueous, plus 2e electron, 2 electrons. So that means zinc is becoming this, where this is zinc after it loses 2 electrons, and this are the 2 electrons it loses. And this is an oxidation reaction. And then right here, usually used for reduction, is when this is the electron that already lost 2 electrons, and now it gained not this, hold up. It gained those 2 electrons, and now it becomes the standard element. It goes back to solid. So this was aqueous. So over here, it's normal copper, but without the 2 electrons, and it gains the 2 electrons, and it becomes regular copper. So this is oxidation half reaction, and this is a reduction half reaction. And how all this applies to galvanic cells is that a galvanic cell is basically a transfer of, so these 2 electrons are going to be transferring with each other. Galvanic cells are transferring of, I'm going to draw it out first. So say 2 different beakers. One of them has they both have aqueous solutions in here. Remember I told you the cations are aqueous. And one of them, this is zinc, and then a metal zinc is in here. Let me write it. Zinc, metal, and then copper, metal, regular metal without the charge. So what's happening here is that this is that's not relevant yet, but the electrons from here is, so this is so what happens here is the zinc, like I told you earlier, is this is the standard zinc, and this is the one where it lost 2 electrons. That's why it's positive. And then those 2 electrons that it lost goes from this side to that side. So the electrons move that way. If you're asking a test where does the electrons move in a galvanic cell, it's from the left to the right. Let me label it the E. The electrons move here. And what happens is after those 2 electrons that this zinc lost, when it comes over here, it goes into this solution. And remember, this is think about it, this is the copper where it's missing 2 electrons before it becomes copper. So those 2 electrons that left here come in and they fill in these 2 holes left in this copper 2+, and then it becomes this solid, this copper in here. So the electrons come from here and go in the solution, then they mix with this, and then they bounce back and they create this. So this increases in mass because copper is what's being created, while zinc is losing electrons, and zinc is lost in mass and copper is increased in mass because zinc becomes this, loses electron, and then copper goes from the aqueous solution and becomes the solid copper. And then this is the main idea of a galvanic cell. And then another thing to complete the galvanic cell is something called the salt bridge right here. Also an important part of, and then let me just redraw it. Another important part of this chapter, because you could a lot of questions that could be formed with the salt bridge. And basically what the salt bridge does is, so over time, as more zinc 2+ is forming, a lot of this is going to build up a positive charge, while this is going to build up a negative charge. Since we're going from 2 to 0, we're going from 0 to 2. So positive charge is building here, negative charge is building here. And something to stop that from happening is called a salt bridge, which usually has compounds. Like, I'm going to give an example, like NaCl, which is a salt. That's why it's called a salt bridge. You know, NaCl is your regular table salt, or it could be KCl. Basically, I think most common salt can be a salt bridge. And if you remember, in NaCl and KCl, I'm just going to use one of them so it's less distracting. I'm going to use KCl. In KCl, the K is the positive and the Cl is the negative part. And what happens in these is that, so remember I told you this was a buildup in positive charge, while this was built up in negative charge. The positive side goes from the, I'm going to start with the negative first. The negative part of the salt bridge goes to this side to be with the 2+. Because remember, negative opposites attract. Negative go to positive, positive goes to negative. So here, the negative goes to this side, and then it becomes zinc chloride. So it neutralizes the 2+, and then the K goes over to this side, because as this is forming, it goes from 2+ to to Cu. The K goes over to that side, because if you remember earlier, the electrons are going over to this side, so this side is getting an excess negative charge, like I said. So this K the positive K has to go over to this side to neutralize the negative charge that it's getting. KCl, the K. And one more important thing that could also be asked in a test and important to understand the galvanic cells is the naming. So this is called the electrode, which is where basically the metal part that goes in the cation solution. Remember, this is a solution, and this is the solution. This is called the electrode, and then the left side is called the anode, while the right side is called the cathode. And the electrons always flow from the anode to the cathode. And I think the name is quite the opposite of what I expected it to be, because the right side is more negative while the left side is more positive. But I guess you could remember it with where the salt bridge goes. The anion part of the salt bridge goes to the anode. The cation part of the salt bridge goes to the cathode. Another important thing to remember about the galvanic cell is it creates electricity. That's basically why this is a galvanic cell. Is a kind of it's part of electrochemistry, which it's a type of electrochemical cell. And if you can't tell by now, electricity, you can harness electricity from the movement of these electrons. And so a galvanic cell creates electricity, which is this E. The E moving is a current, and later on you learn about the units and stuff. But that's a cool thing that galvanic cell does. That's why I like galvanic cell, because there's an actual real life application for it, and you can work on it in the labs and see actual electricity voltages and all that. And that's the simple form of the galvanic cell.